The Moon is located very close to Earth. A round trip by spacecraft takes about 8 days. Meanwhile, the neighboring planets of Earth, Mars and Venus, are much farther away, and the travel time is much longer than to the Moon. So, how long does it take to reach Mars, Mercury, and the other planets? On July 16, 1969, the largest rocket in history, the Saturn V, was launched. It carried the manned lunar exploration spacecraft, Apollo. The time from launch to the lunar surface was about 102 hours. After arriving on the Moon, the spacecraft departed again. It took roughly the same amount of time to return to Earth. The total travel time was about 8 days. The distance between Earth and the Moon is about 289,000 miles. Venus. Venus is the planet closest to Earth. The closest distance between Venus and Earth is about 24.5 million miles. That is 100 times the distance to the Moon. The first spacecraft in human history to successfully land softly on Venus was the Soviet Venera 7. Venera means Venus in Russian. It was launched on August 17, 1970, and landed on Venus on December 15th of the same year. Thus, the travel time from Earth to Venus was about 4 months. By the way, after entering Venus's atmosphere, Venera 7 deployed its parachute at an altitude of about 37 miles. At the same time as parachute deployment, it observed the components of Venus's atmosphere. It revealed that 97% of Venus's atmosphere consists of carbon dioxide. Mars. The planet closest to Earth after Venus is Mars. Unlike the scorching Venus, Mars has a cooler climate, making it more suitable for human exploration. Therefore, Mars has been explored far more extensively than Venus. Timing is crucial when traveling to Mars. As you know, Earth and Mars orbit the Sun with different periods, causing their distance to change dramatically. It is necessary to depart Earth when Mars is approaching. The cycle of Earth and Mars moving closer or farther apart is about 2 years and 2 months. On September 11, 2035, Mars will come closest to Earth in over a decade. The distance will be about 35.4 million miles. How long does it take to reach Mars? This is the trajectory of the Mars probe InSight. To reach Mars from Earth, the spacecraft must first accelerate enough to escape Earth's gravity. If it does not accelerate enough, it will either fall back to Earth or remain in Earth's orbit. On the other hand, if the spacecraft accelerates enough to escape Earth's gravity, it will pass by Mars unless it slows down upon approach. Therefore, the spacecraft must decelerate when approaching Mars. When moving between two celestial bodies, it is necessary to calculate the optimal trajectory considering the gravity of both bodies. German aerospace engineer Walter Hohmann proposed a trajectory that minimizes the required energy when transferring from one circular orbit to another. This is called the Hohmann transfer orbit. The InSight trajectory mentioned earlier uses the Hohmann transfer orbit. The time taken to reach Mars was about 6.5 months. When traveling to Mars, one must spend about half a year inside the spacecraft. Half a year might be manageable, but the problem is the return trip. Since the spacecraft departs Earth when Mars is closest, by the time it arrives at Mars, Earth will be moving farther away. Therefore, the astronauts must stay on Mars until Earth approaches again. Including the stay on Mars, the total travel time for a Mars trip is about 3 years. Mercury. The planet closest to Earth after Mars is Mercury. The closest distance is about 57.8 million miles. This is not much different from the distance to Mars. Therefore, the time to reach near Mercury is about 5 months, similar to Mars. If you can go to Mars, Mercury might seem reachable as well. However, in reality, traveling to Mercury is the most difficult among the planets in the solar system. Why is it harder to go to Mercury despite its proximity? The reason is that capturing Mercury's gravity requires an enormous amount of energy, rather than just passing by. Let's look at the relationship between Mercury's position and gravity. This is the gravity well created by the Sun. Since the Sun has a large mass, the well is very deep. Mercury creates a small gravity well along the way. Compared to the Sun, a planet's mass is small, so the well is very shallow. This is because the Sun accounts for 99.86% of the total mass of the solar system, and all other bodies combined make up only 0.14%. Compared to the Sun's gravity well, Mercury's well is nearly invisible. When a probe is launched toward Mercury, it accelerates rapidly in the Sun's deep gravity well and easily passes Mercury. Therefore, to stay at Mercury, the probe must continuously decelerate to avoid falling into the Sun. The energy required for this deceleration is tens of times that needed to reach Mars. The probe must carry huge amounts of fuel and decelerate continuously with a super-large rocket. If this is done successfully, the time taken is about 5 months. However, developing a rocket capable of producing tens of times the energy to reach Mars is unrealistic. How, then, does a spacecraft slow down enough to be captured by Mercury's gravity? It uses planetary gravity assists and orbital motion. The European Space Agency and Japan Aerospace Exploration Agency jointly launched the Mercury probe Bepi Colombo on October 19, 2018. This is its trajectory from launch to near Mercury. First, 1.5 years after launch, it uses Earth for deceleration. The image taken at that time shows the probe giving Earth a small amount of orbital energy, while the probe itself slows down and begins moving toward Venus. Similarly, the probe uses Venus twice for deceleration and heads toward Mercury. At this stage, it is still too early to be captured by Mercury's gravity well. Therefore, it uses Mercury 6 times in total to decelerate. After that, the probe finally succeeds in being captured by Mercury's gravity well. Once captured, it changes its orbit and settles into a stable one. The time taken to reach this point is about 7 years. Mercury is a much more distant celestial body than imagined. Jupiter. The distance to celestial bodies beyond Mars increases drastically. The distance from Earth to Jupiter is about 370 million miles at its closest and about 559 million miles at its farthest. The fastest probe to reach Jupiter was the interplanetary probe New Horizons. It used the Atlas V rocket, with a special third stage added for New Horizons. It was launched on January 19, 2006, and accelerated to 10.1 miles per second using the third stage. It passed the Moon's orbit in just 9 hours due to its incredible speed. Then it passed Mars's orbit in about 3 months. On February 28, 2007, 1 year and 1 month later, it reached Jupiter's closest point. Probes passing Jupiter can reach it within 2 years. On the other hand, the probe Juno, which targeted Jupiter, took about 5 years to enter Jupiter's orbit. Still, it is possible to reach Jupiter in a shorter time than to Mercury. Saturn. Famous for Saturn exploration is the Cassini spacecraft. It clarified the three-dimensional structure and dynamic behavior of Saturn's rings and investigated its moons. The distance to Saturn is about 746 million miles at its closest, roughly twice as far as Jupiter. Therefore, Cassini used gravity assists to speed up and shorten travel time to Saturn. This is Cassini's trajectory. Cassini passed Venus twice to gain speed, then Earth for acceleration. At this point, it reached speeds exceeding those needed to surpass the asteroid belt. After that, it also accelerated near Jupiter and headed toward Saturn's orbit, successfully being captured by Saturn's gravity well. The time from launch to entering Saturn's orbit was about 7 years. Uranus and Neptune. Uranus and Neptune are located even farther than Saturn. Their closest distances from Earth are about 1.62 billion miles and 2.67 billion miles, respectively, making them extremely distant. The only probe to approach both planets was Voyager 2. It reached Uranus's orbit in 8 years and 5 months, and Neptune's orbit in 12 years. Voyager 2 was able to explore both Uranus and Neptune because of their positions. Due to differences in orbital periods, Uranus and Neptune sometimes lie on opposite sides of the Sun or on the same side. Voyager 2 was launched at the optimal time when both planets were on the same side. The distance to Neptune is about 2.67 billion miles. That is far beyond human reach. However, as with the difficulty of reaching Mercury, the required travel time to a celestial body is not simply determined by distance. In other words, celestial bodies that seem unreachable might not be as far as we think. Voyager will take tens of thousands of years to leave the solar system. The day when space exploration, combining our science and technology, surpasses Voyager is surely near.